Code please.
We say that a function is recursive when it calls itself. And that might be a little bit strange, especially if you never programmed before. But trust me when I say that it's very useful when you want to execute the same kind of operation over a list of items, or dealing with hierarchies or networks or graphs. It's typically very useful to use recursion in some of these situations. And to exemplify recursion, we're going to take a look at the most common example for this, which is the Fibonacci sequence. And the Fibonacci sequence is nothing more than a mathematical sequence where you keep adding the previous two items in a sequence of integers. So let's say we have the 0, then next we have the 1, and now if we add 0 and 1 we get 1. Now if we add 1 plus 1, so basically always the last two items, we get 2. If we add 1 and 2 we get 3, so forth and so on. And in order to generate this, we can see that there's a pattern here, and this pattern can be solved quite elegantly using recursion. Let's do that. Let's define a new module called myProject.Fibonacci. And typically the first thing you do in recursive functions is define the stopping conditions. Basically, otherwise the function is just going to run itself forever. It keeps calling itself and it's going to run forever and never stop. So you need to define some kind of end clauses, so to speak. Let's start with our first end clause, and we're going to call it we're going to define a function called fib, that if you pass the argument 0, you get 0 out of it. Okay, and this is a cool thing about Elixir, is that you can pattern match function calls to explicit values. You don't really need to just accept a variable as an argument to a function like in most other languages, but you can be very specific about what a function does when it receives a very specific kind of input. In this case, if you call fib with 0, you get 0. So let's define another end condition, and these are basically the end conditions for the first two elements that we know for sure what the value is, and we just saw before. So 0 is 0 and 1 is 1. And now we can define the Fibonacci sequence recursively. So we can define the recursive part of the function. We're going to say that fib of n, of any arbitrary value that we pass in, is going to be fib of n minus 1 plus fib of n minus 2. So it's going to be the sum of the previous two values. So let's say we want to calculate fib of the Fibonacci sequence for the number 3, for instance. What's going to happen is that we're going to call fib 3, and this in turn is going to create, it's going to call fib of n minus 1, which is 2, plus fib of n minus 2, which is 1. And I'm just going to put some dots because I don't want this to get evaluated, but what's going to happen is then Elixir is going to call fib with 2 and fib with 1, and it's going to kind of aggregate all these results until it reaches the end conditions. And we can see that already fib of 1 is already an end condition, and we know the result of this. This evaluates to 1. So, and this one is actually going to call itself again with fib 2, and it's going to resolve to fib 1 and fib 0, which is going to be 1. So if we call fib 3, or if we call myProject.Fibonacci.fib3, we get 2. And this is true because remember the sequence. The sequence is 0, 1, and 1. So when we're calculating, this is going to be fib of 0, this is going to be fib of 1, and this is going to be fib of 2, which is going to be 1 plus 1. And you get 2. So this would be the fib of 3, basically, that we are calculating here. And you can see exactly how the Fibonacci sequence is calculated here. We first call fib of 3, which then translates into fib of 2 plus fib of 1. fib of 2 is basically fib of 1 and fib of 0, and at this point we reached the end conditions for all of the branches. So we know what fib of 1 is and fib of 0 is, and so we can calculate fib of 2 by just adding 1 and 0, which is 1, then we add 1 plus 1 on the top branch, and we end up with 2. And that's it for this video. On the next video, I am going to explain a little bit about more complex types like maps, lists, keyword lists, tuples. We're going to explore a little bit about modules that the Elixir language provides in order to manipulate these kinds of more complex structures. So until next time, cheers! If you like this video, please consider subscribing and liking and sharing with your friends. It really helps the channel to grow. Thank you.